In this video, we're going to focus on graphing exponential functions, including functions with base e, but we'll cover that later in the video. So let's start with a simple function, y is equal to 2 raised to the x power. How can we graph this particular function? What would you do to graph it? The best thing to do is to make a table, and you want to plug in the right points. Personally, I would pick a 0 and 1. Now this function has a horizontal asymptote. The horizontal asymptote is the x-axis. It's y equals 0. Now if you see a number like plus 3, the horizontal asymptote will shift 3 units up. So it's now y equals 3. So if the function was 2 to the x minus, let's say 4, the horizontal asymptote is y equals negative 4. But if you don't see that number, then it's y equals 0. It's the x-axis. Now, if we plug in 0 into the function, 2 to the 0 power is 1. Anything raised to the 0 power is 1. 2 to the first power is 2. And then simply plot the points. So we have the point 0, 1, and 1, 2. Now start from the x-axis, that is the horizontal asymptote, and connect a graph to the 2 points. So that's the graph of the function. That's all you got to do. Now what are the domain and range of this function? Let's start with the domain. How can we write it in interval notation? The domain of any function represents the x values that the function can have. For exponential functions, it's always going to be negative infinity to infinity. The lowest x value that we see on the left side is negative infinity, and the function can keep going to the right. There's no restrictions on the value of x. We can plug in any value for x. Now what about the range? The range is the y values that the function can have. The lowest y value is 0. It starts from the horizontal asymptote. The highest y value goes up to infinity. So it's from 0 to infinity, but it does not include 0. There's no value of x that you can plug in that will make y equal to 0. So this is the range. Let's try another example. Let's say that y is equal to 3x plus 1 minus 2. So the minus 2 tells you that the graph has been shifted down 2 units. So the horizontal asymptote is y is equal to negative 2. Now, x plus 1, that tells you that the graph has been shifted 1 unit to the left. The standard x values that we should typically choose are 0 and 1. Now, if it's been shifted 1 unit to the left, then instead of plugging in 0, we're going to plug in negative 1. And instead of plugging 1, we're going to plug in 0. To find those x values, you can set x plus 1 equal to 0 and equal to 1, our original values. And then if you solve for x, you should get negative 1 and 0, the new x values that you should plug in. So now let's go ahead and make a graph. So let's plot the horizontal asymptote at y equals negative 2. And let's plug in the numbers. So let's start with negative 1. 3 raised to the negative 1 plus 1 minus 2. Negative 1 plus 1 is 0. 3 to the 0 is 1. 1 minus 2 is negative 1. Now what is the value of y if we replace x with 0? 0 plus 1 is 1. 3 to the first power is 3. 3 minus 2 is 1. So now let's graph it. So we have the point negative 1, which is here, and 0, 1, which is there. So to graph it, start from the horizontal asymptote and connect to the 2 points that we see here. So it's going to go in that direction. Let me see if I can do that better. There we go. So now what are the domain and range of the function? As we said before, the domain of the function is the same. It's all real numbers, negative infinity to infinity. Now for the range, the lowest y value begins at the horizontal asymptote, -2, and the function goes up towards positive infinity. So the range is -2 to infinity. Let's try this one. Let's say y is equal to e to the x minus 1. Now even if you have the base e, the rules are still the same. E is just a number. E is about 2.718, but let's use 2.7 just to keep things simple. Now just like before, we're going to plug in two values into x, 0 and 1. When x is 0, y will be equal to 0. E to the 0 is 1, 1 minus 1 is 0. Now when x is 1, what is the value of y? E to the first power, which is e, that's 2.7. 2.7 minus 1 is 1.7. And the last thing we need is the horizontal asymptote, which is y is equal to -1. So we have plenty of information to graph the function at this point. So let's plot the horizontal asymptote, which is not there. It's over here. The first point is 0, 0, and the next point is 1, 1.7, which is approximately there. So as before, we're going to start from the horizontal asymptote and connect to the 2 points. And so that's a rough sketch of the curve that we have. The domain of the function is negative infinity to infinity, and the range is from the horizontal asymptote up to positive infinity. So the range is from -1 to infinity, but not including -1. Try this one. Let's say y is equal to 3 minus e to the x minus 2. So what values should we plug into the table? If you're not sure, set the exponent, in this case x minus 2, equal to two numbers, 0 and 1. Therefore, the x values that we should choose are 2 and 3. The graph has been shifted 2 units to the right. So instead of choosing 0 and 1, add 2 to both of those numbers. Now what's the horizontal asymptote? The horizontal asymptote is the constant that you see in front of the function, which is in this case 3. You can rewrite the function like this if you want. Now notice that we have a negative sign in front of the exponential term. That negative sign is going to cause it to reflect over the horizontal asymptote. So the horizontal asymptote is y is equal to 3. So before, the graph was above the horizontal asymptote. Now it's going to be below it. Now let's plug in these values into the equation, and let's get the y values that correspond to them. Let's start with 2. 2 minus 2 is 0, e to the 0 is 1, and 3 minus 1 is 2. Now if we plug in 3, 3 minus 2 is 1, e to the 1 is e, which is 2.7, 3 minus 2.7 is 0.3. So let's plot the horizontal asymptote, which is y is equal to 3. And we have the point 2, 2, which is right here. And we have the point 3, 0.3, which is here in this general vicinity. So always start from the horizontal asymptote and follow the 2 points. So the graph looks something like that. So the domain is going to be the same, negative infinity to infinity, but the range is a little different. Starting from the bottom to the top, the lowest y value is negative infinity, The highest in this case is the horizontal asymptote of 3. So the range is from negative infinity to 3, but not including 3.